Okay, we're ready to finish this graphing unit up now. Let's look at two graphs that are probably the hardest of the ones that we're going to look at. These are the graphs of tangent and cotangent. And before we graph, actually, I want to do a little review with you. If I were just to make a column, a little chart of angle theta and the tan of theta, and we'll just stick in the first quadrant. Let's put 0, pi over 6, which is 30, pi over 4, which is 45, pi over 3, or 60, and pi over 2, or 90. And we were to list these values for tangent. The value of tangent of 0, you can check your unit circle, but it's 0. The tangent of pi over 2 is undefined. The tangent of 45 is 1. The tangent of pi over 3 is the square root of 3, which is approximately 1.7. And the tangent of pi over 6 is the square root of 3 over 3, which I'm just going to put approximately 0.6. So basically what happens is that the tangent in the first quadrant goes from 0 up, 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 and then somehow it gets to undefined. And the idea is, let's just look at it right here. Between 0 and pi over 2, it goes from 0, that's 45 right there, so to 0.6 to 1 to 1.7, and then somehow it zooms to infinity, and that's why there's an undefined. Undefined means an asymptote. So that's what tangent looks like in the first quadrant. Now in the second quadrant, it comes from, this would go from pi over 2 to pi. This is the second quadrant. Tangent is negative, so it's basically coming like this, and it's coming back to 0. In the third quadrant, which goes from pi over 2 to 3 pi over 2, tangent is undefined at 3 pi over 2, so you're going to have a similar thing. Tangent is positive in the third and undefined at 3 pi over 2. And then the fourth quadrant is going to come back like this. Now, the reason I just sketched out this graph before we started is because let's talk about the idea of the period. We've talked about functions. Trig functions are periodic. That is, they repeat themselves. And, you know, the sine had a period of 2 pi. That was sine. And the cosine had a period of 2 pi. That was cosine. And because the secant and the cosecant go with the sine and the cosine, they also had periods of 2 pi. But if you look at what we just drew for tangent, this one goes up and back to 0, up and back to 0. So what I want you to do is look at this shape right here. And then look at this shape right here, and what you see is a repeat of the same thing. This tangent curve is doing 2 of these things in the space of 2 pi, which means that the period of tangent is this right here. The period of tangent and cotangent is pi. And this is huge. This is the thing that most students miss when they work with tangent and cotangent graphs. Because tangent, let's go through the quadrants, 1, 2, 3, 4. Tangent is positive in the first, negative in the second, positive in the third, negative in the fourth. You see that pattern? That's a period. And that's the same period again. So period of tangent is 1 pi, not 2 pi. And therefore, when we look at the tangent graph, its period will be pi over b and not 2 pi over b. Okay, let's go and look at ordinary graph now. Suppose you were to graph y equals 4 tan 2x. Okay, well, let's talk about it. The amplitude is 4, and we'll see what that means on this graph. You know, amplitude on sine and cosine means height. Amplitude on secant and cosecant means sort of height. It's how low and how high, but in reverse order. And the period of this graph is 1 pi over b, which is pi over 2. This is still A, this is still B. We can still shift these graphs. We can still move them up and down, left and right. But in this one, we're just going to draw it normally. Now, here's how we're going to draw this. We're going to go from 0 to pi over 2. And we're going to go up to 4 and down to -4. Now, there's some things you need to know about the tangent graph. First of all, take this, half it, pi over 4, half it again, pi over 8, multiply by 3, 3 pi over 8. Now, just as we've kind of memorized what goes on in a period of all the others, let's memorize what goes on in a period of tangent. There will be an asymptote right down the middle. Whatever the period is, asymptote will be right at the middle. Tangent will begin at 0 and will end at 0. At the first point beside 0, it will be at the amplitude. So that tells you how tall it's going to be. And it will go towards the asymptote there. At the fourth point, it will be at the negative amplitude, and it will come from infinity and zoom back. This is one period. Now, remember, it keeps going like this, and it goes on and on forever. So I don't want you to think that tangent is two separate pieces that don't hook to anything. They're this continuous set of little whips that grow this way. And we will usually graph 2 periods of the tangent. Now, while you're looking at this tangent graph, let's talk about cotangent. Cotangent is the inverse of tangent. And so let's think about what that means. First of all, let's have the same period. It'll be 1 pi over b instead of 2 pi over b. But where tangent goes up, cotangent will come down. Where tangent has an asymptote is in the middle of this period, cotangent will cross over the axis. And where this one has a 0, it will have an asymptote. Cotangent will have an asymptote. So what I want to do is I want to take another color, if I can find one, and I want to draw the cotangent graph right over this one so you can see how it behaves. Remember, tangent has an asymptote, cotangent will be at 0. So let's put a 0 there. Where tangent was at 0, cotangent will have an asymptote. So we'll have asymptotes at the beginning and end of the period. And then it's going to come right through this and go right down there. Now what you're seeing on the red is y equals 4 cotangent to x. It's the opposite of tangent. Look how this one, tangent is rising, cotangent is falling. Tangent is at 0, cotangent has an asymptote. Tangent has an asymptote, cotangent has a 0. Tangent has a 0, cotangent has an asymptote. Tangent is rising, cotangent is falling. Okay, so let me summarize tangent and cotangent for you on this next sheet as far as basic shapes and see if this will help you a little bit. All right, y equals tangent x and y equals cotangent x. What do you need to know? Well, the first thing is normal period for both. Pi over b. Pi over b. Asymptote. For tangent, middle of period, no matter where that is. For cotangent, asymptote, beginning, end of period. Just the opposite, you see. You got 5 points. This one's going to have its asymptote in the middle. This one's going to have it at the beginning and the end. Tangent's basic graph is going to start at 0, move towards an asymptote. It's going to go like this and like this. That's one period. Cotangent is going to have the asymptote at the beginning and at the end. It's going to cross in the middle. It's going to come high, go low. When you look at them on a calculator, this one's going to look like this. This one's going to look like this. So it's going to be hard to tell them apart. This one's going up, 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 up. This one's going down, 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 down. Of course, if you have a negative one of these, it goes like this and like this. If you have a negative one of these, it looks like that. And that's when it really gets confusing, because a negative cotangent looks a lot like a positive tangent. And a negative tangent looks a lot like a positive cotangent. So you just have to pay attention to what you're doing. These can also be shifted, stretched, raised up, down. Let's just we have time for one more. Let's look at y equals -3 cotangent 4x plus 2. That's got a little bit of everything except a horizontal shift. This is A, this is B, this is D. Let's see if we can get this. We're going to graph it in stages. So the first thing I'm going to do is I'm going to stretch out my period. My period is, well, my amplitude is -3 or 3. My period is, this is cotangent, pi over 4. My vertical shift is going to be up 2. There is no horizontal shift. And it is, as you can see, negative. So the first thing let's do, let's put the amplitude on there, 3 and -3. And let's stretch out a period, 0 to pi over 4. We're going to half that, pi over 8. Half that, pi over 16. Multiply by 3, 3 pi over 16. And cotangent will have asymptotes at the beginning and at the end. So the axis serves as an asymptote. And it will cross in the middle. So what I want to do is I want to put a dot in the middle. Now normally cotangent is going to come high and fall, but this is negative. So it's going to go up and up like this. It is negative and then positive. Okay, now that is -3 cotangent 4x. Then I need to pick the whole thing up 2. So what we're going to do is we're going to pick every point up 2, which is, there's not very many to move. We're going to shift this 0 up here. We're going to keep the asymptotes, and basically we're just going to move like that and like that. The asymptotes don't move, of course, they stay in the same place. So this is basically what the graph of negative cotangent 4x plus 2 looks like. We'll have some practice problems in class, but I wanted you to see that. The main thing is to know what the period is, pi over b, and where the asymptotes are for your basic graphs. As we look at our review before the test, we'll talk about period and asymptotes for all 6 graphs. Your test will be at the end of the week, and you'll want to be sure that you can graph each of the 6 graphs, stretch them, shift them, move them up and down, left and right. I have not done a horizontal shift of either of these. We'll do that in class. That concludes our videos set for graphing these trig functions. I hope you've enjoyed it. I hope you find it easy, and I'll see you in class tomorrow.